At this research center in Olean, New York, the world's most advanced high-pressure centrifugal compressors are conceived and developed.
Dresser Clark has built and tested a centrifugal compressor for high-pressure natural gas injection. This compressor consists of 2 cases in a train. There's 12 impellers operating at a speed of 10,400 RPM and 22,000 horsepower.
The design pressure of this machine is 10,500 psi. Our ability to design and manufacture this compressor is a result of over 30 years' experience.
Dresser Clark's most sophisticated centrifugal compressor. This vertically split machine incorporates many of the unique design features pioneered by Dresser Clark. The 2-stage train consists of 1 low and 1 high-pressure unit. The extreme pressures the machine must contain require that the forged steel casing walls be a full 12 inches thick. One of the most unique features of the compressor is the patented shear ring head retainer. The induced couple effect of the shear ring design means higher pressure containment in a smaller diameter casing and end head. It also offers greater accessibility to seals, journal bearings, and the Michel-type thrust assembly, and thus easier and quicker maintenance. Other patented Dresser Clark components include the oil film seal and the tilt pad bearing. In the 2 decades since their initial development, the components of the oil film seal have undergone continuous improvement. Today, they are capable of handling discharge pressures of over 10,000 psi, assuring positive gas seal, coolant to the rings, and minimum seal oil drain loss. The patented Dresser Clark tilt pad bearing, in addition to the tilt pad seals, contributes to support of much higher bearing loads and improved rotor dynamics. The heart of the system, the rotor shaft. A product of Dresser Clark's long-standing expertise in rotor dynamics, this rotor consists of 6 impellers in back-to-back configuration. The result? A pressure-balanced design, which greatly reduces high thrust loads during upset conditions in the field. The back-to-back construction requires a crossover mechanism, and Dresser Clark has designed and manufactured a truly unique system. Discharge from one section of the rotor to the other is carried entirely inside the casing, eliminating the need for external nozzles in intercooling. Dresser Clark also offers revolutionary impeller design. Low-capacity operation requires extremely narrow channels. Normal welding procedures cannot be used, so Dresser Clark has developed an advanced slot welding technique. The result is a stronger, more efficient, longer-lasting impeller. Dresser Clark's expertise in the design and manufacture of centrifugal compressors is supported by a multi-million-dollar test facility.
Our quality control, both from an engineering and a manufacturing viewpoint, is confirmed in our test facilities here in Olean. We've actually run these units at over 20,000 horsepower and 10,400 RPM. And because of the facility, we are able to adjust for pressures and speeds that are over and above what the contract conditions would require.
As centrifugal compressor design has become more sophisticated, Dresser Clark has continually increased its testing capabilities. The Olean test facilities include a complete closed-loop cascade system for simulating all types of on-site application. For natural gas injection testing, inert nitrogen is used and all data converted for differences in molecular weight. The Clark steam plant employs a condensate system, including cooling towers for optimum power flexibility. The test compressors are powered by steam turbines, capable of achieving any drive requirements up to 26,000 horsepower. The main structure contains 11 test stands, able to accommodate the down-connected closed-loop piping. Overlooking the test stands is the data center, which houses online acquisition and evaluation equipment. Today's higher pressures and stringent operating conditions demand the ultimate in monitoring and analysis. Dresser Clark's sophisticated electronic equipment meets that challenge with real-time data collection, computer performance evaluation, and multi-program capability. A number of operating parameters can be measured, including speed, vibration, temperature, pressure, and flows. Data input is collected from a series of sensors on the machine itself. The real-time system provides instantaneous collection and analysis of 115 separate data elements. Readout of essential parameters is also available to the floor crew, who are in constant communication with the data center during test runs. The culmination of intensive testing of this high-pressure train, Clark makes its final contract test run on the compressor, built for the Philips Norway Group's Ekofisk platform.
During the test, we will be operating and driving the compressors with a steam turbine, a high-pressure and a low-pressure steam turbine driven through a compound mixing gear into the contract gearbox and then into the two compressor cases. The steam turbines are part of our test facility, rated at 26,000 horsepower. We'll actually be using approximately 22,000 horsepower for the test that we're conducting.
Thank you. Would you confirm when you get those bottles on for me, please?
Well, I think we need just a little bit more pressure there.
The test begins when controls are switched from the floor to the data center.
Okay, I'm opening the header valve now. The bubbles are on. Thank you.
Vibrations okay, Bob?
Yeah, Bob.
Seal and gas pressure are built up slowly, and each performance parameter is closely monitored every step of the way.
Mr. Winkler, would you check the Section N 181B seal oil, please? It's our running component. 173? Right, it's showing 0.2 of a mil there. Gear frequency contribution. Looks like another 0.2 at 81 CPS, 2.15 gear ratio. Pretty clean. A little blip is twice gear.
Dresser Clark's advanced data systems are capable not only of evaluating performance during the test, data can be stored and recalled in simulating test runs to aid in field operation and minimize downtime. Continuous online calculations confirm that all systems are functioning well within limits as contract speed and pressure is approached. Leaders in many industries have come to witness for themselves the results of Dresser Clark's technological expertise. Although this compressor will be used for natural gas injection, the same know-how in design, construction, and testing is applied to every machine bearing the Clark label. Whether it be petroleum, gas, chemical, petrochemical, process, Whatever the industry, Clark has a machine to handle the job.
Yeah, just a minute, I gotta get that speed right. Okay, that's about 10,480 on the speed.
The compressor achieves the objective. Contract pressure of 9,200 psi, meeting all specifications for vibration and temperature. Exhaustive testing continues. Stops and starts, overspeed, endurance runs. But Dresser Clark is not satisfied in simply meeting contract requirements. As a conclusion to the demonstration, the engineers proceed to an even higher project objective for this high-pressure train. The target, 10,500 psi.
I was going to tell you I put on the fan of the tower. Yes, sir, thank you. B3, I'm about 6.5 tens.
Looks like we're about up to pressure there now. Let's take another reading on that.
I'm interested in that coupling guard temperature.
Coupling guard, right there.
Every part of the system is subjected to the closest scrutiny, examined and re-examined to ensure the highest quality to the customer.
Speed looks like it's holding.
Let's try to throw that C valve and get the 181B up to about, well, try for 5,900 pounds.
Okay, Bob, I'll close down on valve C just a little bit.
Back off on the discharge a little bit.
Performance is confirmed for all mechanical parameters. The compressors exceed all hydraulic objectives, including pressure rise, capacity, and efficiency.
181B inlet vertical valve is reading about 0.45 mils. 181B discharge is at 1.3. 191B vertical looks like about 1.2. Discharge on the 191B is running right around the mill. Primarily all 1 times running frequency. Everything looks pretty steady at this point.
Pressure reading 10,400 psi and rising.
Okay, we're running along steady at 10,535 psi discharge pressure.
Dresser Clark, from gas turbines to axial compressors, from pipeline boosters to gas engine and reciprocating compressors. Dresser Clark, through expertise in design, manufacture, and testing, the recognized leader in high-pressure technology. Dresser Clark, one of the many dimensions of Dresser Industries, serving energy and industry worldwide.